By UTC, it's 11 o'clock, and it's actually 1.347 billion Unix time. on YouTube, I think that I've produced the most advanced videos on Möbius strips, only because I've turned them into knots, well, frame knots and then knots, and I've been looking at the Jones polynomial and the knot notation and taking them apart with Whitney tricks. Oh, and I found an anomaly last night. I worked out the Jones polynomial for the three main groups. Now, this is a Möbius strip. It's just a manifold that's non-orientatable. It has one edge, one surface, three flips. So if you start here, and if you go in one direction, you end up back where you started. But if you cut it down the middle by adding an edge, that adds an extra boundary, so you end up with a manifold that has 8 twists, 2 edges, and 2 surfaces. And what I've been doing is adding half snips, so then the planes can cross each other, and it takes 6 intersections to flatten the Möbius strip. And then if you put it on a plane and then transfer that to knot notation and take account for the crossings, like here, it's an overcrossing. So you can see this one comes from above. So here's a knot notation, and this is one of the knots, and it's really quite a beautiful knot because it's kind of symmetrical, but not really. However, that knot comes from the Lorentz attractor in chaos theory. It's the exact knot that you'll see in the Lorentz. That was one little discovery I made. But then there's all kinds of other knots. So here they are. There's what I call the braid group. I only found 2 examples of that. There's a group with a non-alternating figure of 8 knot in the middle, and there's a trefoil knot, which is just 3 crossings. And I worked out a Jones polynomial, and I get all these coefficients, but this one here has a Jones polynomial of 1. And now, Jones in 1984, I mean, this is the forefront of mathematics, and this is really recent stuff. Jones said that, I wrote this down more simply. Jones said, calculate JK, and if it isn't 1, this means the knot can't be unknotted. JK is 1 for the unknot. So basically, all these knots came from the same manifold just by rearranging the folds. They should all have the same coefficients, 4, 3, and 1, or -1, or +1. But this one is an anomaly. It means that if it isn't 1, it means it can't be unknotted. It means this can be unknotted, but it can't be, because when I take that apart with the Whitney trick, this is the that's not the same one, sorry, but I know that this one has the same result. So I took it apart with a Whitney trick, where you just have to imagine that one, I guess, boundary is transparent. We can just slip it across. That's a Whitney trick, and we get the unknot. But when you do that to the braid group, you get a knot with 4 loops, and the 4 loops represent the 4 loops that are left in the Möbius strip when it's cut down the middle. And Jones, he developed a group of knots called the braid words. And you can see these are the braids. So ultimately, a 3-flip Möbius strip, as far as I know, it makes this braid kind of word. These are those types of knots. But this is only got 3 flips. If you add 5 flips, it gets infinitely more complex, like almost NP complete, or 7 flips or 9 flips. So there's a whole plethora of these knots. I've only been working on 3-flip Möbius strips. So right now I'm really scratching my head why this JK is 1 for this knot when they have the same etiology. They're made the same way. It's almost like it's impossible. So real head scratcher. So I was up late last night thinking about it. So this is my favorite knot. This is just really pretty. That's just really cool. And you can see what the Möbius strip is. You know, here it is, here it's a manifold. And I found another thing interesting. When I added a mutation to the trefoil knot and just reversed it, this Möbius strip, which is, you know, a loop with 3 flips, becomes this manifold with 3 separate, it's like 3 propellers attached together with a half twist on each prop. So you can see, when we take the Möbius strip and get this knot notation, if we do a mutation to these 1, 2 crossings and make it this crossing, when you put the edges back together, you get this manifold. So I've done a transformation, which was really, really cool. I did that in my head one day when I was feeling a bit clever. Well, then I confirmed it with the models, with the notation.